So I'm going over Chapter 20, Problem 20.32, and the question is, 29 college students identified as having a positive attitude about Mitt Romney as compared to Barack Obama in the 2012 presidential election. They were asked to rate how trustworthy the face of Mitt Romney appeared. They represented in their mental image of Mitt Romney's face. They wanted to compare their trustworthiness of that face and rank it on a scale from 0 to 7. So 0 would be not at all trustworthy, and a 7 would be extremely trustworthy. So here the 29 ratings are actually listed here in the problem. So each of these is what the rating of each of the 29 students is, or 29 college students is. And so the first question is, suppose we consider this an SRS of all U.S. college students. So this is a true random sampling of all college students in the U.S., and we make a stem plot. So I already have the stem plot, so I will pop this up in the window here, and you can see that the stem plot, if we look at it, is we could have actually broken out the 3s and the 4s into their 2 separate rows and done half on each, and you would have seen that it's relatively normal, and it's slightly skewed. If you actually break those columns 3 and 4 out into 2 columns each, you'd see that it's slightly skewed to the right. But overall, it's pretty normal. And so, is there any sign of major deviation from the normality? And the answer would be no, not really. There's no outliers to the far right or to the far left of this sample. So it looks like this is a pretty good representation of the U.S. college students here. So the second question is, give a 95% confidence interval for the mean rating. So to get the confidence interval, we're going to need some information. So first we're going to need the mean of all of these samples that were taken. So the mean, of course, is just calculated by adding all of these scores up and then dividing by the total number of scores taken, which was 29. And if you do that, you should get 3.938. So this is our mean, x bar. And we also need to know the standard deviation. So to calculate that, we can actually use software. And if you go into software and you type equals, or you go into any kind of spreadsheet program and you type equals, and then standard std, I believe is dev dot s for sample, because we are using a sample, you should get 0.806 as your standard deviation. So again, in software, that would be, I'll just write this in a different color, that would be stdev.s, and then you would write you would select the entire sample size, so all values in sample here. So that might be a range of something like A2 to A30, for example. Okay, so once you figure out the standard deviation, the third piece of information that you're going to need is the degrees of freedom. So remember, degrees of freedom is the sample size minus 1. So in this case, it would be 29 minus 1, which is 28. So we have 28 degrees of freedom. Okay, so to calculate the confidence interval for 95%, we're going to use a formula. And the formula for determining this confidence interval is going to be, I'll just write it again in a different color, is going to be x bar, the mean, plus or minus some critical value, which we will get to in a minute, multiplied by s over the square root of n, which is essentially the standard deviation calculation here. So a standard deviation over the square root of the total number of samples, excuse me. So now, the question now becomes, well, what is this t star? How do I get this critical value here? Well, the critical value can be obtained by looking at a t-table. So I have a t-table right here, and in this t-table, we're going to look for this critical value t. So let's find this value here in our table. So we know two pieces of information. We know that we want to find the value at 95% confidence interval, right? So a 95% confidence interval. And we know our degrees of freedom are 28. 29 minus 1 is 28. So how do we figure this out? So if I go to my table, I can go down to 28 degrees of freedom, which is right here. I can go to that 28 degrees of freedom, and now I know I have a 95% confidence interval, which is this column right here. So if I kind of hone in on this row in this column, you can see that I get to this value right here, 2.048. And that is my t star value, or my critical value. So now I can go and I can move on. So this now becomes, this whole thing we can rewrite as x bar, which we know is 3.938, is plus or minus some interval. So it is the critical value t, which we determined was 2.048 from looking on our chart, our t chart here, confidence level chart. And we know the standard deviation is 0.806. We could have done that the long way as well, but it's much easier to do it in software or on your calculator. And now we divide that by the square root of 29, which is our sample size. Now if we go ahead and do some of this math, what we will get, so the square root of 29 is actually 5.385. And if we multiply all of this together, we end up with 3.938 plus or minus, I believe it comes out to 0.307. So now if I add 0.307 to this 3.938, and then I subtract 0.307 from 3.938, I should get two values, a low and a high value. And if you do the math there, you get something close to 3.631 to 4.245. And this is our range that we're looking for. So 3.631 to 4.245 is the confidence interval that we're talking about. So essentially we're saying that the mean is actually going to fall somewhere between 3.631 and 4.245 95% of the time. So that is part, I believe that was part B of the question. Now part C is asking if the significance, is there significant evidence at the 5% level that the mean rating is greater than 3.5, a neutral rating, because it's exactly halfway between 0 and 7. So now they're asking a different sort of question. And to answer that question, what I'd like to do is just draw the graph. I'm running out of room, but let's see if we can maybe get rid of this and then just erase some of the board here. We should be able to draw our graph right here. So, okay, so I'm going to draw a normal curve And on this normal curve, what we've determined is that our mean is 3.938. So our mean in the center here is 3.938. And then what we determined is that with 95% confidence, we know that things are going to fall between two values. They're going to fall between 3.631 and 4.245. So essentially we're saying the mean is always going to fall somewhere in this range here, 95% of the time. Not always, but 95% of the time. So the question in part C is asking, is there evidence at the 5% level that the mean rating is greater than 3.5? Well, 3.5, if we draw this on the graph, 3.5 is less than 3.631. So 3.5 might be somewhere around here. And that is outside of our 95% confidence interval. So what that means is that we essentially are saying, we would essentially reject this, this hypothesis that because it is, we have enough evidence to say that whatever rating comes through, we have, with 95% confidence, can say that it's going to be more than 3.5. It's going to be higher than 3.5. So another way to think of this is we had a hypothesis. Our null hypothesis essentially states that the mean is equal to 3.5. And our alternative hypothesis states that the mean is greater than 3.5. So if you look at this graph, since our 3.5 is outside of the range within 95% confidence, then we can actually say that there's significant evidence that the mean is going to be greater than 3.5, because we can say that with 95% confidence. So that's the answer to part C. And that is the question.